Why do snakes lie on the road at night, and how does this relate to asteroids? Join the 3-2-1 science team as we explore the concept of thermal inertia. What is thermal inertia? To better understand this concept, let's break the term into two words and look at each separately. We'll start with inertia. Inertia refers to the tendency of something to resist change. For example, a heavy bowling ball has lots of inertia. It's hard to lift and throw, but once it's rolling down the lane, it's hard to stop, and will keep going until it hits the barrier at the end, hopefully taking some pins along with it. Because the bowling ball resists changes to its motion, we say it has a lot of inertia. The word thermal refers to temperature. Thermal inertia, then, is the tendency of something to resist changes in temperature. Beach sand, rocks, and water all have different thermal inertia. Rocks and water have high thermal inertia, which means they take a long time to heat up and cool down. Beach sand has a much lower thermal inertia, so it heats up and cools down much more quickly. Desert snakes make use of the thermal inertia of an asphalt road to regulate their body temperature because they are cold-blooded. During the day, the asphalt warms up in the sunshine and the snakes sleep under rocks. But at night, when the temperature gets cool again, the snakes come out and warm themselves on the road, because the road has a higher thermal inertia than the air and the sand of the desert, so it releases heat much more slowly as the night cools. Planetary scientists study the thermal inertia of the surfaces of solar system objects. Measurements of the thermal inertia of an asteroid surface provide useful information about the asteroid. The thermal inertia can tell scientists where boulders and small, loose rocks are on the surface, and thus where to find the best sample material. Thermal inertia measurements also play a key role in determining the strength of the Yarkovsky effect for that asteroid. This can ultimately affect whether or not a particular asteroid's orbit will intersect the Earth's. NASA's OSIRIS-REx mission will measure the thermal inertia at the surface of asteroid Bennu to help predict whether Bennu will be a threat to the Earth in 200 years. You can learn more about the OSIRIS-REx mission, the Yarkovsky effect, and Bennu by clicking on the links. This video is an OSIRIS-REx production. OSIRIS-REx is a partnership of the University of Arizona, NASA Goddard Space Flight Center, and Lockheed Martin.